Every serious fintech breach has the same root cause. Someone trusted the wrong boundary. In this module, you'll start looking at your architecture the way attackers and regulators do, by tracing where identity data crosses domains and spotting the quiet places where trust can fail. When you design identity, eKYC, and AML systems, the critical factor isn't each individual service, but the boundaries between them. A trust boundary is that exact handoff point where data or control crosses between different security policies. Every one of those crossings creates a threat surface, concrete ways an attacker can interact with your identity flows. As architects, our job is to shrink those exposed surfaces and enforce strong, verifiable controls at every boundary, not just inside services. In most fintech identity flows, think about a chain of actors passing trust along. The user starts on a client device, usually the weakest, least trusted environment. API gateways form the first enforcement layer. They terminate TLS, apply basic checks, and shield downstream services. Identity providers handle authentication and issue tokens that represent who the user is. KYC and AML vendors enrich that identity with risk signals. Finally, internal core systems consume all of this to update ledgers and customer profiles. Now add a second lens to those flows. Look at trust boundaries in two dimensions at once. First, network boundaries, internet, DMZ, and internal zones. Here you worry about perimeter defense, routing, protocol security, and threats like interception or DDoS/EOS. Second, organizational boundaries, your systems, your vendor systems, and regulators. Here the real issues are data ownership, liability, and misuse. A single API call often crosses both dimensions. For each such transition, explicitly document the required controls for both network and organizational risk. It can help to view the onboarding journey as a sequence of trust, gates the request must pass through. Between the user and your edge, you're defending against hostile networks and devices, so you lean on strong TLS, strict input validation, and often mutual TLS. Inside the backend, the focus shifts to authenticated service-to-service calls and least privilege access. When you cross into third parties and internal cores, you add contractual controls, payload encryption, tokenization, network segmentation, role-based access, and immutable audit trails to contain blast radius. Identity systems sit in the critical path for who is acting and what happened. That makes a few stride categories especially important: spoofing, tampering, and repudiation. So don't just protect the perimeter. Apply threat modeling at every boundary transition between apps, APIs, vendors, and internal services to understand how those three threats show up in your specific flows. For spoofing in identity systems, you're really defending on three fronts. First, client spoofing. Assume credentials, SIMs, and even devices will be stolen or cloned. You counter that with tight device binding, strong multi-factor authentication, and rich anti-fraud telemetry. Second, document and biometric spoofing. Deepfakes and high-quality forgeries demand active and passive liveness checks and multimodal verification, not just one selfie. Third, service spoofing. Protect machine-to-machine trust using mutual TLS and cryptographically signed API requests. Tampering is about silent modification of critical data, not just stealing it. Start by protecting identity attributes. Names, dates of birth, and addresses need integrity guarantees in transit and at rest, using TLS plus digital signatures on payloads, not only on the channel. Next, protect KYC and AML decisions. Treat the pass or fail outcome as a signed object, or at least MACD, so it can't be flipped in the middle. Finally, harden session state with encrypted tokens, strict change control, and worm-style audit logs. Repudiation is about believable deniability. A user or internal service can say, "I never did that," and your logs can't confidently prove otherwise. The root problem is usually logging that's fragmented and easy to alter, with no strong binding to who acted, from which device, and under what consent. To fix that, treat audit as a cryptographic chain. Every event time-stamped, hash-linked to the previous one, and enriched with correlation IDs and explicit consent artifacts. Underneath all of this, think about trust in three layers: technical, process, and organizational. Technical trust is your cryptography, protocols, and gateways behaving as expected. You control it with key management, algorithm choices, and patching. Process trust is believing your KYC workflows and vendors actually do what the contract claims. Here you use due diligence, SLAs, and ongoing sampling. Organizational trust is assuming counterparties and regulators govern correctly, enforced with audits and legal agreements. Your role is to make these assumptions explicit, then separate justified, controlled trust from blind, risky trust. Those trust assumptions become concrete when they're written into service contracts. Performance SLAs capture the technical expectations: how fast KYC decisions must return, how systems degrade under load, and what good enough resilience means. Security SLAs turn vague worries into specific requirements for key management, tokenization, logging, and incident response timelines. Identity SLAs pin down accuracy and behavior: acceptable false positive and false negative rates, ray verification frequency, and how disputes are handled. Anything not captured here remains an implicit, risky trust assumption. Once identity data leaves your platform, architecture has to be backed by strong data sharing agreements. First, purpose limitation. Define precisely which flows may use the data and explicitly forbid secondary uses like marketing unless reconsented. Second, retention and deletion. Encode hard lifecycle rules in the system, not just in policy documents. Third, data localization. Your routing layer must respect jurisdiction and cross-border rules. And throughout, build auditability in, so every transfer is provable and roles are unambiguous. Regulators don't just care that you made a decision. They care that you can prove how you got there. You want a single, unbroken story from user action, through IdP events and KYC decisions, to the final business outcome. That demands universal correlation IDs, consistent logging schemas, and append-only, reconciled logs across every vendor boundary. If an investigator asks, "Why was this customer approved or blocked?" your architecture should let you replay that decision path in seconds, cryptographically anchored. This framework ties everything together into one mental model. First, always model the threats. Use stride or similar techniques so every identity flow is explicitly challenged and every trust assumption is written down. Second, harden the boundaries. Minimize what crosses each boundary and enforce every transition with strong authentication, authorization, and cryptographic proofs. Third, govern the trust. Turn these designs into contracts, SLAs, and verifiable audit trails, and keep them updated as threats, vendors, and regulations evolve.